I'm fairly certain this is going to be a three-part section, just not because we have that many problems left to do. It looks like we only go up to problem 27. It's just that the length of number of parts each question has kind of makes, 20 questions into 100 questions when each one has like 5 or 6 parts. The first few are just looking at graphs and interpreting the intervals where the graph is increasing and decreasing and finding the maximum and minimum points. So those will go quickly, but then eventually we'll just bog way down. I had problem 1 up on the screen. Let me do problem 2. Problem 2 just gives me a picture and asks me to find where the graph is increasing, decreasing, the coordinates of the relative maximum point, the relative maximum value, the coordinates of the relative minimum point, the relative minimum value. You don't need to show any work like I'm about to show here. You should be able to write this down by inspection. For quickness, that point -2, 4 is the relative maximum point. And the point 2, -4 is the relative minimum point. So when I went and typed up my answers, when I said the relative maximum point is the point -2, 4, that's because I realized that that's a maximum point. And when I answered part E, the coordinates of the relative minimum point are 2, -4. That's just by inspection. And then the relative maximum values and the relative minimum value is always the y coordinate of the point. So for parts D and parts F, the y coordinate of the relative maximum point is the relative maximum value, which means any point close to it is going to have a y coordinate less than 3. It may have x coordinates bigger than -2, x coordinates less than -2, but all the y's are going to be less than 4. So to say the relative maximum value is y equal to 4 when x equal to -2, that's just what we generally say when we try to describe the y coordinate of a maximum or minimum point. And then similarly, the relative minimum value is the y coordinate of the minimum point, and meaning any point close to it may have x's less than 2, may have x's bigger than 2, but any point close to it, its y is going to be bigger than -4. So the relative minimum value is the y coordinate of the minimum point, and then we say when or which occurs when x equal to 2. Those are freebie. Those are just numbers directly in the problem already. If I wanted to talk about the increasing and decreasing intervals, by inspection or by doing what I'm doing right now, I'm going to divide the graph into regions. The first region is going to go from the far left edge of the x-axis, which starts at -infinity, to the x coordinate of the maximum point with round parentheses, which is -2. This region has, if I drew a tangent line to a point, it would have positive slope. So this is an example of an increasing interval. Similarly, if as I'm drawing the graph, my marker is moving away from me when the graph is increasing. The middle interval between the maximum and minimum point goes from the maximum point, which has an x coordinate of -2, to the minimum point, which has an x coordinate of +2. So when I describe this middle interval, it's the interval from open parentheses or round parentheses -2 to round parentheses +2. And this region is decreasing. As I'm drawing it, my marker is getting in some sense closer to me. This is a decreasing interval. And the last interval starts at the x coordinate of the minimum point, which is x equal to 2, goes to the far right edge of the x-axis, and the x-axis ends at infinity. This is also another increasing interval because as I'm drawing my marker is moving away from me. And now I just need to split these intervals up into their appropriate spots. So the interval from -infinity to -2 and the interval from 2 to infinity, I put in my answer for where the graph is increasing. Putting the union symbol between, that's just the appropriate symbol when you have multiple intervals that are doing the same increasing or multiple intervals that are decreasing. And then the middle interval I just wrote decreasing for. To save some time, I'm going to skip number 4. We did something like it, I think, in the first video, and move on to a graph that's a little bit different. It's not particularly hard, but it's more of a W shape, and we haven't looked at a graph like that to answer these questions, so I felt like I should do that. That's your problem 5, and I'm about to do problem 6, and it's going to look a lot like it pictorially. And so let me answer all the questions that I just answered relative to this graph. In this W-shaped graph, I didn't get the points labeled. I don't know why, but this point is the origin. It's the point 0, 0, and it's a relative maximum point. I'm just going to write max next to it. And this point down here is the point -1, comma -1, and it's lower than anything close to it, so it's a relative minimum point. And this point, +1, -1, is also a minimum point. So when I go to answer the maximum question and the minimum question, or the maximum questions and the minimum questions, the points themselves, the coordinates of the relative maximum point goes in part C. So the point 0, 0, the maximum point goes in part C. And the two minimum points, the point -1, -1, and +1, -1, those go in for the coordinates of the relative minimum point. In this case, to say the relative minimum value is a little bit different. The relative maximum value part, the C and D, are kind of married together. I first say the relative maximum value, and then I write the y coordinate of the maximum point, in this case is 0, and then I tack on some words that attach the x to it. So the y equal to 0 goes first, the x coordinate goes second. It's a little bit different for these because there's 2 points, but they have the same y. So when I write the information about the relative minimum value, I only need to write the -1 once, because both points have the same y coordinate or the same minimum value. And then because there are 2 points, I need to mention both of their x's when I answer part F. So I said the relative minimum value is -1 when x is negative or +1. I separated them with a comma as opposed to a union. That's just the way it's normally done. I didn't get to pick what's normal, so I just live with what's normal. Now to do the increasing and decreasing, I'm going to make intervals. First, the interval to the left of the first minimum point. That's going to go from the far left edge of the x-axis, which is an x-coordinate of -infinity, to the x-coordinate of the minimum point, which has an x-coordinate of -1. This, as I'm drawing on it, it's getting closer to me. This is a decreasing interval. The middle interval goes from the x-coordinate of the first minimum point to the x-coordinate of the maximum point. That's going to go from -1, the x-coordinate of the minimum point, to 0, the x-coordinate of the maximum point. And this is an increasing interval. As I'm drawing on it, my marker's moving away from me. If I draw a tangent line, it has positive slope. So this middle interval, or the second of 4 intervals I'm going to get here, is going to be an increasing interval. And then I define the region between the maximum point and the second minimum point. That's going to go from the x-coordinate of the maximum point, which is 0, to the x-coordinate of the minimum point, which is 1. And this is another decreasing region. As I'm drawing it, my marker is getting closer to the bottom of the page, closer to me. That's what a decreasing interval does. And the last interval starts at the x-coordinate of the second minimum point, which is 1, goes forever to the far right edge of the x-axis, which has an x-coordinate of infinity. And this is another increasing region, because as I move from left to right, my marker is getting closer to the top of the page or further away from me. So there's 2 increasing intervals, the interval from -1 to 0 and 1 to infinity. I put both of those intervals in my answer to part A, which is to say what the increasing intervals are, separated them with a U. And there were 2 decreasing intervals, -infinity to -1 and 0 to 1. I put those in my decreasing answer, separated those with a union symbol. 7's a parabola. We haven't done parabolas yet, so we should. And I'm going to do 8. When I look at the graph of a parabola, it doesn't have both a maximum and a minimum point. My vertex of this parabola is just a minimum point. So when I go to answer the questions about the maximum, there isn't a maximum point. And you need a point looking, graph humping up like that. There isn't a maximum point. So for part C and part D, the questions about the maximum, for this parabola, there is no maximum point. But there is a minimum point. The coordinates of the relative minimum point is the point -1, +6. And the relative minimum value is y equal to 6, which is the y coordinate of that minimum point, and then we say which occurs or when x equals to -1. In order to split the graph for increasing and decreasing, I only get one split because there's only one minimum point and there's no maximum point. The left interval that I'm going to describe goes from the far left edge of the x-axis, which has an x-coordinate of -infinity, to the x-coordinate of the minimum point, which is -1. And then the next interval is going to go from the x-coordinate of the minimum point, which is -1, to the far right edge of the x-axis, which has an x-coordinate of infinity. This first interval is a decreasing interval because as I'm drawing it, my marker is getting closer to me or getting closer to the bottom of the page. And the second interval is an increasing interval because my marker is getting closer to the top of the page or is pulling away from me. So when I answered, the second interval I put in the increasing, the first interval I put in the decreasing. Of course, we need to be able to do upside down parabolas because they can come either way. They could actually go left and right, but those aren't functions. We don't study those in our class. So for problem 10, that point -1, 3, it's a maximum point, and there is no minimum point. So when I answered the minimum parts for question 10, I just said there was no minimum point, no minimum value. And then the maximum point was the point -1, 3, and I just said the relative maximum value is the y-coordinate of the maximum point, which occurs when x equals to 3. To do the increasing and decreasing, I split the graph. To the left of the maximum point, it goes from the far left edge of the x-axis, which starts at -infinity, to the x-coordinate of the maximum point. And this is an increasing interval. And then to the right of the maximum point, that's the interval starting at x equal to -1, the x-coordinate of the maximum point, going off to infinity. And that's a decreasing interval, because my marker, again, is going closer to the bottom of the page or closer to me. So I put the increasing interval in my answer to part A, the decreasing interval in my answer to part B. 11 and 12 are the graphs of fractions, and they have asymptotes. And we're going to have to try to guesstimate where the asymptote is the best we can, because that's going to be the edge numbers, the beginning and ending numbers for the intervals. This is pretty tough to see. I didn't font up the axis enough, but on problem 12, the gap that's in this graph is at -3 on the x-axis. I need to be able to figure out where the halves of the graph are breaking up, and one graph breaks up at the left half here is at -3, and the right half is at 1. I can't really draw these as well as I'd like to draw these. I should have drew them on my computer because it would do a better job. But when there's a fraction graph like I have here, we need to segment on either side of the asymptote. In this point right here, this line, this is actually a minimum point. It almost looks horizontal, this line, but it's real subtly dipping and then coming back up. This is going to be the minimum point, and that's going to be winding up in my answer to part E. I don't have a maximum point. Like, this point's not considered a maximum point because there's points to the right of it that are higher than it. This bend here is not considered a minimum point because there's points to the right of it that are lower than it. So this graph, it has a minimum point, barely can tell that it's a minimum point, but I took the time to mark it, so it had to be something. The minimum point's the point -3, positive 4.32, which means the minimum value is y equal to 4.32, which occurs when x equals to -3. There is no maximum point, so for both of the maximums, I put none. When I go to describe this, I need to break this graph up into regions. The region to the left of the vertical asymptote, the region between the first vertical asymptote and the minimum point, the region between the minimum point and the second vertical asymptote, and the region to the right of the vertical asymptote. So this first region, I'm going to describe it going from the far left edge of the x-axis, which is -infinity, to the x-coordinate of where the break in the graph is, which is at -3. And this is a decreasing interval. As I'm drawing, my marker is getting closer to the bottom of the page or closer to me. Then I have the break, In my second region, it's also decreasing. As I'm drawing on that region, my marker is getting closer to me or closer to the bottom of the page. But these are two distinct intervals. They're not connected, so I can't combine those to a single interval. And this interval goes from the x coordinate of the, I guess that's supposed to be -5. I have a mess up here. I can't read. I have my reading glasses on, but I still couldn't read this. Because I should go, this is origin -1, -2. Hold it. This is, I can't even tell. This is not -5. This is -1, -2, -3.4, -4, -5, -6. That's actually -7. Sorry, I can't read. I blew it on the font here. This region is supposed to be -infinity to -7, just counting by 1 over from the origin. I should have realized that was -7, but I didn't. So the first region, still a decreasing region, goes from the far left edge of the x-axis toward -7, where this graph breaks. The second region goes from -7, where the graph breaks, to the x-coordinate of the minimum point, which apparently is -3. The middle region goes from the x-coordinate of the minimum point, which is -3, to the x-coordinate of this asymptote, which is 1. And this is an increasing region. And then the last is from the x-coordinate of the asymptote to the far right edge of the x-axis. That's also an increasing region. So I need to take these two regions, -infinity to -7, along with -7 to -3, put them in my decreasing, separate it with a union, and those two regions separate it with a union in my increasing. Now the algebra. My guess is I'll get to do kind of one of each kind of problem. This kind of problem I refer to as a polynomial. Maybe we can get two of them done on this video. And then in the next video, we'll probably do fractions and ease. So let's me work on number 2, which is a nice parabola, and answer all the parts the best I can. So first question wants me to find the derivative. Super easy derivative. To find the derivative, that's just a generic power rule, no special product or quotient or chain rule. I just take the 2x squared, multiply the 2 by 2 and get 4, lower the exponent by 1. And then for the -8x, its derivative is -8. The positive 1, its derivative is 0. So the answer to part A, the derivative is 4x minus 8. Part B wants me to find critical numbers. And for a polynomial, critical numbers are just the values that make the derivative 0. So I just set the derivative equal to 0 and do the algebra to solve for x. This gives me 4x equals to 8. Divide by 4, divide by 4. My answer to part B is x equal to 2. Now I'm stuck. I'm basically going to get the rest of the answers in one giant computation. Now that I've found the derivative and the critical numbers, I'm going to plot the only critical number on a number line with negative and positive infinity to get going. So this is now going to be probably simultaneously C through H. I can't really do these one at a time. So I'm going to create a number line that's going to have negative infinity on the far left edge, positive infinity on the far right edge, and the only critical number of 2 between the infinities. So this, I saved this from the last video. So I found the critical numbers, I plotted them on a number line that has negative and positive infinity, and I'm going to create intervals with only round parentheses. My first interval is going to be the interval from negative infinity to positive 2. My second interval is going to be the interval from positive 2 to positive infinity. Next, I'm going to pick a number inside each interval and plug it into the derivative. The first interval, I'm going to plug in 0, because 0 is such an easy number to pick, and 0 is in this interval. The second interval, I'm going to plug in 3. I like picking small numbers, so I usually pick numbers right to the edge of the critical number, as close to the critical number as I can. And now I'm going to evaluate those in the derivative. So I'm going to do f prime of 0 is 4 times 0 minus 8. And that comes out to minus 8. And I'll do f, the derivative evaluated at 3. That's going to be 4 times 3 minus 8. And I'm just doing the simple math in my head. That comes out to 4. So I picked a number, I plugged it into the derivative. Now I need to determine whether the graph is increasing or decreasing. In this region, the graph is going to be decreasing because I got a negative result. In this region, the graph is going to be increasing because I got a positive result. So now I could answer this interval 2 to infinity goes in the increasing interval. That interval negative infinity to 2 goes in the decreasing interval. So done with actually C and D. Now it's just E, F, G, and H. To do this now, so I determined whether the graph was increasing and decreasing. The graph was increasing because when I had a positive result. The graph was decreasing when I had a negative result. Now I'm going to place my directional arrows to determine if I have a maximum or a minimum point, and then I'll find y coordinates. So first interval is decreasing, so I draw a decreasing line, or a line with negative slope. Second interval is increasing, so I draw a line with positive slope. This right here tells me that 2 is the x-coordinate of a minimum point. I don't see any arrows that meet like this, so there's no maximum point. So for both of my maximums, I put none. The algebra gives me the x-coordinate of the minimum point. It doesn't give me the y-coordinate. Turns out the minimum point is 2, -7, but to get the y-coordinate of the minimum point, I need to use the original function. So the y-coordinate of the minimum point, I'm going to go f of 2 equals 2 times 2 squared minus 8 times 2 plus 1, just to make sure I don't have an error on my key. 2 times 2 squared minus 8 times 2 plus 1, I get -7, which is good. So this is the y-coordinate of the minimum point. This is the x-coordinate of the minimum point. So my minimum point is the point 2, -7. I finish out the problem by just describing the minimum value. The minimum value is the y-coordinate of the minimum point, which occurs when x equals to 2. The next problems, 15 and 16, I said let's skip for time. I kind of knew that was going to happen. And you can skip those as well for homework. I'm going to move on to the 17 and 18 world. 17 is your problem. 18 is my problem. They're both cubes. I think I did 18 in the example. It looks like the same problem. So I'm going to walk through 17 with you. And then we'll call that the end of part 2 and move on to a part 3. So for 17, you can pause the video and try it. Let's do part A. The derivative is a simple derivative. I just use the power rule. The derivative of x cubed is 3x squared. The derivative of minus 12x is minus 12. The derivative of 4 is 0. Done with part A. I'm moving on to part B to find the critical numbers. I find the critical numbers by taking the derivative and setting it equal to 0. I'm going to solve this by factoring. First, I'm going to pull out a common factor of a 3 and be left with x squared minus 4. And then I'm going to factor the x squared minus 4 into x plus 2 times x minus 2. So now I have it completely factored. I can set each of the factors equal to 0. The first factor, because it doesn't have a variable, doesn't give a solution. The middle factor, if I minus 2 from both sides, it will give me a critical number of -2. And the last factor, if I add 2 to both sides, it'll give me a critical number of 2. So in terms of my answers, part A, the derivative is 3x squared minus 12. Part B, the critical numbers are -2 and +2. And now in one giant computation, I'll start to get everything else. So I'm going to work on this C through H. And what do? I create a number line that has negative infinity on the far left edge, positive infinity on the far right edge, and the two critical numbers in this case, -2 and +2 between the infinities. I'm just going through these steps, but I kind of have them memorized. Found the derivative, found the critical numbers, plot the critical numbers on a number line that has negative, positive infinity 2. Now create intervals using only round parentheses. So my first interval is going to be negative infinity to -2, and then -2 to +2, and then +2 to infinity. After I create my intervals, I pick a number inside each interval and plug it into the derivative, figure out if the graph is increasing or decreasing. In my first interval, I'm going to plug in -3. I can't plug in 0 because it's not in this interval, so I just pick a number real close to the edge. In the middle interval, I'm going to plug in 0 because 0 is an easy number for me to do, and it's inside that interval. And in the last interval, I'm going to plug in 3 because I can't plug in a better number like 1 or 0 because it's not in that interval. For each one of these now, I'm going to evaluate the derivative at that number. So I'm going to go the derivative evaluated at -3 is going to be 3 times -3 squared minus 12. And then I'll do the derivative evaluated at 0, which is going to be 3 times 0 squared minus 12. And then I'll do the derivative evaluated at 3, which is going to be 3 times 3 squared minus 12. That's calculator worthy, so let me try this. So first, 3 times -3 squared minus 12, I get 15. 3 times 0 squared minus 12, I get -12. And then 3 times 3 squared minus 12, I get 15. I often get duplicates in these values because of the way I pick the points being the equidistant from the critical number. So I've plotted the values in, and now I can decide whether the graph is increasing or decreasing. The graph is increasing if I get a positive result. It's decreasing if I get a negative result. So this guy right here is increasing. So in my answer to increasing, I'm going to put the interval from -infinity to -2. The middle result came out negative, so the graph is decreasing. So the interval from -2 to +2 is going to be a decreasing. In the last interval, because I got a positive, it's an increasing. There's a second increasing interval that goes from 2 to infinity. So I'm done with C and D. In order to figure out if I have maximums or minimums, I place directional arrows, either increasing or decreasing arrows, and see how they meet up to figure out if I have a maximum or a minimum. So first interval is increasing, I draw a line with positive slope. Second interval is decreasing, I draw a line with negative slope. Third interval is increasing, I draw a line with positive slope. So at x equal to -2, there's a max. So the maximum is the point -2 comma something. At x equal +2, there's a min. You can see the difference between the max and the min points. And the min is 2 comma something. To get the comma somethings, I need to use the original function. So get the y coordinate of the max, I need to use the function, not the derivative, and go y equals to -2 cubed minus 12 times -2 plus 4. And to get the y coordinate of the min, I do y equals +2 cubed minus 12 times +2 plus 4. I'm just taking the values of the critical numbers, plugging them into the original function. So for the max, it's -2 cubed minus 12 times -2 plus 4. And I get 20. So the max is the point -2, +20. And then for the y coordinate of the min, 2 cubed minus 12 times 2 plus 4. The y coordinate of the min, if I haven't made a button pressing error, which can easily happen, is -12. So I have everything done except the part where I just split the max and split the min to do the maximum and minimum value. So for part F, the relative maximum value is y equal to 20, and I'll say which occurs when x equals to -2. The relative minimum value is y equal to -12, which occurs when x equal to 2. Barring any mistakes, because I'm doing this problem without the answer in front of me, this should be the correct answer for your homework problem 17. And then the next thing we're going to do is work with a fraction, and that's a whole different animal. We haven't done one in the example. They're not particularly hard. a lot of times the fractions don't have maximums or minimums, so they actually get to be a little bit easier. Let me pause the video and we'll do a part 3.